All right, so it looks pretty good. Let me just talk about one of them. So some of you will have recognized that 1000 is 10 to the power of 3. So maybe, because I've got 31,000, I could say this is 31 times 10 to the power of 3. And I would agree with you. This conversion is correct. But there's something about this number 31 that it's not that it's wrong, it's just that it doesn't meet the convention that we set out last lesson. Does anyone remember what that convention was? Do I just want to use any number A here? Think back to Monday. You wrote it down in your notes if you were taking notes. Hmm? No? Don't know? Okay. So let me remind you, the first number that multiplies the power of 10, this number needs to be between 1 and 10, and we don't include the 10. But we include the 1. And the reason for this is if I say I've got 10 times 10 to the 5, well, that's the same as 1 times 10 to the 6. Like, do you agree that these two numbers are the same? 10 to the 1 times 10 to the 5, use the index law and you just get 10 to the 6. So we just want a standard form. We only want one way to represent a number using scientific notation. So for that reason, we need to restrict this first number so that it's between 1 and 10. If you've got a number larger than 10, you can very easily fix this by taking out a factor of 10. So I'll just make this quick. 31 is the same as 3.1 times 10. Is that okay? 3.1 times 10 is 31. So I've taken out a 10 there. And I've still got the 10 to the 3 left over. Can you see now? Now I've got a number that's between 1 and 10. Before I didn't. Before it was 31. But because I want to write it in this standard form, between 1 and 10, I needed to take out a 10 here. Okay? So we're still not in standard form yet, because I want times 10 to some number. So Mia, I'll ask you, what do you think? Can you simplify this expression here? Okay. Do you think we've got A, the number between 1 and 10? Yes, we've got 3.1. That's between 1 and 10. All right. So we just need this part now, 10 to the n, yeah? All right, I'm gonna circle the part that's gonna be useful to you. If you apply the index laws to that, can you simplify that? 10 times 10 to the 3. Yes. So 10 times 10 to the 3 is the same as 10 to the 1 times 10 to the 3. Add using the index laws, 10 to the 4. Okay, so this is very common. this is very common when you're first starting to learn scientific notation. You might say, oh, there's 3 zeros, so I'll use 10 to the 3, and there's 31 of them, so I'll put 31 out here. And that's fine, but we want this standard form where it's between 1 and 10 at the start. Okay? So if you get this, that's great. You'll just need to do some simplification to get to here. Okay? If you follow my method, you will always end up with a number between 1 and 10 because we only look at the first digit to start with. Okay? All right. Let's look at some negative, not negative, but decimals now. Okay, so in the second column, 0.02, remember, our goal today is to convert between basic numerals and scientific notation. This is also a numeral, but it's different because now I've got decimals, and the sort of leading digit has a place value that's smaller than 1. So let me just remind you. Lockie, 2 times 10 to the 2, what's that? 200. Talia, 2 times 10 to the 1. Can you simplify that for me? 20. McKenna, 2 times 10 to the 0? 2. Okay, Damon, over to you. 2 times 10 to the minus 1. 0.2. Okay, if you've forgotten, guys, 10 to the minus 1 is the same as 1 over 10. All right, using this index law, a to the minus n is 1 over a to the n. And here I've used n equals 1 and a equals 10. And last year, we spent a few weeks on fractions, decimals, and percentages. 1/10 is the same as 0.1. All right. So Mia, I've thrown you the hardest question so far. What do you think 2 times 10 to the minus 2 is going to be? 0.02? Talia, what do you think 2 times 10 to the minus 3 is going to be? 0.002. Okay, so you guys are getting this, all right? Great. All right, so we've actually got it here. 2 times 10 to the minus 2. So you can write that for your first one, if you haven't already. All right, we can do the next one now. 0.12346. Now, something I want you to notice here. Damon, how many zeros are here? How many zeros have I got between the decimal point and the first non-zero digit? 4 zeros. So the question I'm going to pose to you is this going to be 6 times 10 to the negative 4? You don't think so? Why not? It's 1 0 here, but it's minus 2. 2 zeros here, minus 3. Okay? So you've just got to be very careful about this, that you're counting. You can still count the zeros, but you got to remember when you're after the decimal point, you got to bump it up by 1 and then make it negative. Okay? So let's do an example with some trailing digits. All right, so let's do part A, and I'll do this step by step with you as well. Okay, so step 1, set every digit after the first one to 0. All right, so this is going to give me 0.00004, and then these 3 digits, I'm going to change them to 0. Okay? Step 2. Count the number of zeros between the decimal point and the remaining digit. So, Lockie, how many zeros do I have here between decimal points? There's 4 of them. 4 zeros. Now, based on your observation, Damon, which power should we use? 5. So what do I need to do to this number 4 to get to 5? So what I mean is, so we've got 4 so far, and I want to make it 5, right? Because that's the power we're going to use. So if I were to describe a rule to go from 4 to 5, what are we doing? Adding 1. Thank you. Yeah, it was meant to be a simple question. So add 1. This is your new negative power. So what we're saying here is 0.00004 equals 4 times 10 to the minus, not 4, but 10 to the minus 5. So you add 1, that gives you 5, and then you make it negative. So you get negative 5. Are we done? Okay, are we finished? Yeah.
We still have 3 other numbers.
Okay. What do you suggest we do?
Would you add it on to the power to make it minus 8?
So you want to change this to minus 8, do you?
Yeah.
You do.
Damon said no.
Damon says no. Okay. Why do you think no, Damon?
Because you put a little decimal point after the 4 and chuck the numbers there.
Yeah, that's what I thought, but there's still zeros.
Okay, so maybe this will help, McKenna. We've previously just calculated the scientific notation of this number here, 4000. Okay. So this number here represents 4 times 10 to the minus 5. If you do 4 times 10 to the minus 8, you're going to get this. 1, 2, 3, 4, 5, 6, 7. You're going to get this number. But we actually want to modify these digits. We don't want to move the place value lower. Okay? So Damon is on the right track. He wants to replace the decimal. He wants to replace the digits. So can you tell us a bit more about what you want to do?
Like, chuck the digits after the 4.
After the decimal point.
Yeah.
Okay? All right, so it really is this simple. 4.593 times 10 to the minus 5. So I took away these 3 digits, and now I've just put them back in after the decimal point. Okay? Would you like me to do another one? I'm looking at the back row. Do you want me to do another one? No? Okay. Then I will let you get cracking, and we'll see how you go.